My name's Dan Abbott, and I teach at Southern Maine Community College, and I'm making this video from my parametric modeling class, AEDD170, that's going to take place in a couple of weeks. It's going to start in a couple of weeks. And I'm doing this for two reasons. One is to just welcome you so you can meet me. But the other is to give you a sense of how my classes are going to work, since we will not be in a standard classroom. That would be my preference. I really like teaching. I like teaching in a classroom, but we'll make this work. And I just want to give you a sense of how it's going to work. I have a setup here in my home office where I am right now. I have two monitors. One I'm looking at now is on the left, the other is on the right. I've got my camera in the middle. I've also got a tablet. I've also got a document camera so I can sketch or draw things out if necessary. And most of what I'm going to be doing is going to be concentrated on sharing my screen so you can see how I'm working with the software we'll be using. And the software we're using is SolidWorks. Now, ever since I started teaching this class, I've made it clear that people can use a different program if they want. Inventor is the program people would be most likely to use. But it's been a long time since anyone's done that. So really, we're using SolidWorks. You're going to learn SolidWorks, and that's the software we're going to be using. So what's going to happen is this. I'll be presenting once a week, and I'll present in the first 2-hour block that's scheduled for this class. That will be a required class. You must attend that class. Then I'm going to schedule another 2-hour block in which I'm just going to be here in a Zoom meeting. I'm encouraging you to do your lab work, some of your lab work then for assignments, so that you can then join the meeting if you have a question, or if you want to talk to some of the other students, or you just want to have me available in case something comes up. And I'll be there for the entire period of time and be able to give you assistance if you need it. What I'm going to do right now is share my screen. I'm going to do a little lesson. It's just sort of a brief introduction, just so you get a sense of how this is going to work. So what I'm now going to do is go over here and share my screen. By the way, I'm in a Zoom meeting right now. I'm just the only participant. Normally, you'd see not just me, but you'd see the other people in the meeting as well. I'm hoping that when you join the meeting, you'll do it with your video turned on so that I can see your faces and get a sense of whether or not you're understanding what I say. But you might not have a camera, you might not just like being on video for whatever reason. So I am going to expect you to give me some feedback periodically. I'm going to stop, I'm going to call on each person. I'm going to ask you to indicate whether you understand what I just presented. And when you do that, you can do it either by waving or unmuting yourself and saying something, or holding up your thumb with a thumbs up. But there's also a little thing called a reactor at the bottom of the screen when you do a Zoom meeting, and you'll be able to pick a thumbs up there if you want to do that instead. Right now, I'm going to share my screen, and I'm going to share a screen that has two things on it. One is a document showing a very simple part, and I'm showing it to you in a front view, a top view, and a right side view. I am going to use this as a way of just giving you a sense of how this goes, and I'm going to show you how to use SolidWorks to make that part. So I'm going to now go to SolidWorks itself, which looks like this. Like every CAD program, SolidWorks has a large drawing area. It also has, and it's normally true on the left-hand side, a window where information is kept track of, the history of what you do is kept track of. You also get instructions over there. And then at the top, there's basically a ribbon that has all the commands. Unlike AutoCAD, SolidWorks does not have a command line. There are a very small number of commands that have aliases where you could type the letter L, for instance, and draw a line. But we're going to use SolidWorks the way it was designed, and that means we're going to pick commands from this ribbon up here. I'm going to start a new file. When you do a file in SolidWorks, you have three choices. You're making a part, you're making an assembly of individual parts, or you're making a drawing. There are two ways to approach this. One is to start by saying, okay, I'm putting together a design of something that has multiple parts. You can go and make each individual part and then put them together into an assembly, or you can start with an assembly and kind of lay out the location where you want everything to be and then create the parts in the assembly itself. That's a little more involved and a little more complicated. So what I do in this class is I always start by doing parts, moving then to assemblies, and then moving to drawings of both the parts and the assembly. So in the novice, this is the novice setting here. I'm just going to pick the part and pick OK. Now, the first time you do this, you're going to be asked what unit you want to draw in. Much of what we do in this class will be in metric, but not all of it. Some of it will also be in inch, decimal inch. It's up to you what you want to select when you first set up SolidWorks, but either way, you can always change the units once you've started. If you look over on the screen, I have in the lower right-hand corner, there's the word custom. Now custom, because I set this up already a little differently, but I'm now going to change that to IPS, inches, pounds, and seconds. And I'm doing that so that I can draw in inches. And this is critical in SolidWorks, much more so than it is in AutoCAD or other programs like AutoCAD. You must decide at the beginning if you're drawing in millimeters or inches. You could conceivably draw in feet or meters. That would be a bad idea for most mechanical applications. So really the only two units we're going to use in this class, and the only two units you're likely to ever use, are going to be inches or millimeters. If you do want millimeters, instead of picking IPS, you pick mmgs, millimeters, grams, and seconds. Don't pick anything above that because you'll be drawing in either centimeters or meters, and that will cause not an unsolvable problem, but a major problem for you later on. In fact, in this class, if you start with the wrong units, my solution for that is always going to be to go and start over again. So now we've got this set for inches. Everything you do in a parametric modeling program starts with a sketch. Up at the top, you have a series of tabs, and those tabs are categories of commands. Features are things like holes, fillets, chamfers, raised bosses. We're not going to start with features. We're going to start with a sketch. So I'm picking the sketch tab, and then the tools available to me in the sketch tab are up here. The first tool I need is to say, okay, now I've got the tools available. The tool I want is the sketch tool. Kind of important to recognize that these tabs are simply collections of commands. They don't do anything by themselves. Nothing is happening in this file as I do this, just changing my availability for certain commands. I need to say I want to do a sketch, and I'll pick sketch. Be careful, we do not want to do a 3D sketch, at least not yet. And we probably won't do a 3D sketch at all. If you're sketching, it's going to be a two-dimensional sketch. It has to be on a plane surface. When you first start parametric software, you only have 3 plane surfaces, front, right, and top. Now, if I take a look at what that drawing looked like, the most logical place for me to start this would be in the right side, because that's the side that has the most distinctive shape. So that's what I'm going to do. It's asking me to select a plane. I'm going to pick the right plane. You notice it becomes orange when I do that. And then the view rotates, so I'm looking straight at it, which is known as normal view. This is very critical. You have an origin, because like every CAD program, SolidWorks is based on the Cartesian coordinate system. That means when I do this, I'm looking down at an origin. I have essentially an X and a Y axis. And those X and Y axes, and depending on how you're viewing the screen, could go right, could go left, could go up, could go down. But the thing is, they're all mutually perpendicular. That's the definition of a Cartesian coordinate system. Now, I told you could type the letter L for a line, but we're going to pick everything from the top because that's where most commands are. If you go up here, you'll notice something that looks like a line. If you hover over it, it tells you that it is a line. If you wait long enough, it'll actually show you how to use that command. Now, I come over here instead, showing me it's a circle, shows me how to use it. If I go to the little arrow beside it, it gives me some options. There's something called a center line, which is really actually a construction line. It happens to be a center line type, but you can use it for anything you don't want to turn into an object. It's extremely useful, and we'll be dealing with that right from the beginning when you do your first assignment. What I'm going to do, though, is I'm going to draw a line. And I want that line to start at the origin, because I want that origin to be taken into account when you do anything. And I'm going to start at the origin by dragging my cursor over after just hovering over the origin, and I get what's called a tracking line. Left click, let go. I'm going to go to the origin, left click, let go. And I go up here, left click, let go. Now I could also left click and pull the line down and let go, but then it'll stop drawing lines. All I'm doing right here is sketching, and literally sketching in the sense that I have no idea exactly how big I just drew this. I'm simply sketching the rough shape, which is what engineers have done for forever. You sketch something out, and then later on you go back and you figure out what the sizes are going to be. Now, once you've done this, certain things happen automatically. It assumed, since I was on a tracking line, that I wanted that line right there to be horizontal, which I did, so it made it horizontal. If I didn't want that horizontal, I could go back and say, no, don't make it horizontal. Let me do something else with it. You notice the lines that looked like I wanted them to be vertical are vertical. I also have a little green icon down here, and that indicates a relationship between the end of that line and my origin. And the relationship is a coincident relationship. In other words, the origin and the end of that line are exactly in the same place. Now I'm done with the line, so I can go over to the left and pick the X, pick the check mark, hit the escape key, which is what I normally do. And now I'm ready to add some dimensions. To add dimensions, I'm going to go over here again up to the window, up to the ribbon that has all the various sketch tools. And right there's something called Smart Dimension. Smart Dimension really is smart. If you go to the drop down, you have all these other choices. Very seldom. In fact, probably in this class, only once am I going to have you go and pick a selection other than Smart Dimension. When you pick the Smart Dimension tool, the icon changes. So it's got a little dimension at an angle. It shows you the arrows, shows you the extension line. I'm going to start by saying, what's the overall length of this? I'm going to pick that line and this line. Right up here, I'm going to type in 4. Nothing changes, but it now knows that that length is 4, and it makes all the other distances relative to that the correct side. I'll pick that line, and that line has to be 0.5. I'll pick this line. Oh, actually, that isn't 4. I made a mistake. And here's my mistake. It's 4 in this direction, not over here. It's 2.25 over there. So now I'm going to double click on that 4 and change it to 2.25. This is the beauty of parametric software. It's driven by the dimensions. So it doesn't take much for me to go and say, oh, I meant to have that be something else. So now go back to dimensioning. So the overall height of this is 2.5. I typed 2.53, so I just double click on it and do that. That distance right there is 0.5. So you notice now I've got all the dimension on this, and I know for a fact that I have fully defined this sketch, which I will insist that you do for every single sketch, unless you're putting text in here so you can raise text and have that be part of your object, or you're using an irregular spline for something. Other than that, if you've got normal lines and circles and arcs, you must fully define every sketch, or I will call that incorrect. Now, it's pretty easy to tell when it's fully defined because everything is black. But the only way to know for sure is to look down in the lower right-hand corner, and under their status bar, the words fully defined appear. Fully defined only appears if it's fully defined. If I go back and I eliminate that dimension, it now says it's underdefined because it doesn't know where that line goes right there. Now I go back in, put the 0.5 in, now it knows where it goes, it draws it correctly, and now it says it's fully defined. Now that's just your sketch. What I want to do with this sketch is something called an extrusion. Extrusion is similar to what happens if you have toothpaste and you put it on your toothbrush. Inside that tube, the toothpaste is just a big mass of toothpaste. There's a hole at the end that is round. When you push the toothpaste through that hole, it extrudes into a cylinder. So we're going to extrude this by pushing that shape through. And I'm going to do that shape pushing by going up here to the tabs and switching from sketch to features. Now I'm going to use a feature because now I'm going to turn that into a solid. And extrusion is one of the options, extruded boss or base. I pick that, kind of goes isometrically just so I can see what I'm doing. It'd be possible for me to just kind of pull that out and in and do an extrusion that way. But what I want you to do every time is go over here and put in information that makes that extrusion specific. So I don't want a blind extrusion. In this particular case, because I have a symmetrical part, I'm going to do a mid-plane extrusion. And here's where I put the 4 in because the width of that part is 4. I pick the green check to say I'm done, and now I have the basic shape of that part. Go back, and I've got to take some things away. I've got to put a rounded corner here. I've got to put a hole through it. I've got to take a little bite out of it here. In order to do that, I'll go back, and I'm going to do some more sketching. Everything starts with a sketch, and you have to sketch on a plane. In order to sketch, I need to go back up to the tabs, and you notice we've only used 2 of these tabs so far, and we're making a part. So instead of being a feature, I'm going to go back over to Sketch, start a new sketch. In this particular case, I'm going to put the sketch on that surface. So I just picked that surface. I'm going to draw a circle. So I'll pick the circle command. I'm going to draw the circle on that surface. Now, if I move that around, you can see I've drawn on that surface. What I haven't done is told it exactly where to put that circle, and I haven't told it how big it is. So I go back over to Smart Dimension. I'll pick the circle and say that circle should be 1 inch. It still doesn't know exactly where to put it. Well, I've got another dimension. That other dimension goes from here to that edge right there, and that's also 1 inch. Now, sorry about the phone ringing, but it's going to stop. Now that still doesn't end things. I still don't have a fully defined sketch, and if I'm wondering why not, I can try grabbing the circle, but nothing happens because I've already put a dimension on it. If I grab the center though, it turns out that I have identified the position up and down, but I haven't identified it side to side. Well, I want the center of that to line right up with the origin. So if I look straight at this, and I'm going to look straight at this by pressing the space bar and doing that. Now I can pick the origin, hold the control key down, pick the center of that circle and say line them up. Now I have a fully defined sketch. Everything's black, but the important thing is it says fully defined down here. Go over to features. I'm going to do an extruded cut. And the safest way to do this, and this is more and more critical as your parts get more complex, don't put a distance in here. Come over here and go up to surface and pick the surface where you want that hole to stop. Now I've cut a hole in that. I'm done with that feature. I'm going to go and add another feature by going back to sketch. This time I'm going to sketch on that surface, this top surface. I'll press the space bar and look straight down at it so you can see what I'm doing. I'm going to draw, well, I'm actually planning on drawing an arc, but I'm going to start with a circle. I'm going to snap right to the midpoint of that line, drag that out. Now I'm going to hold the right button on my mouse down and move it up because that gives me the dimension, the Smart Dimension tool. I'm going to say make that circle. Well, let me wait a minute on that. I'm not going to do that yet. I'm going to take that dimension off because what I really want here is not a full circle. I want only a half a circle. So I'm now also going to take that line right there. I'm sorry, that edge right there, and I'm going to turn it into a line. I'm using a tool called Convert Entities. I pick the edge. I do that. Now there's a black line right here. And what I can do now is I can trim that circle to the line. So I have half a circle. I can also trim the line back to the arc like that. Now, when I put the dimension on it, I can actually give the dimension it wants, which is a radius of 1. Now I have a fully closed shape, and you notice that shading tells me it's fully closed. I normally turn that off, by the way, when I'm drawing, but you turn it on and it shows you have a closed shape. Now, that's a fully defined sketch. I come back over to features, and under features, I'm going to do an extruded cut once again. And once again, I'm going to go up to surface. You'll be hearing that from me over and over again. There's a reason. I'm going to try very hard to help you develop habits that prevent problems down the road. I pick the green check, and now I have most of this done. Now I do have a couple of rounds right here. The outside corners of those are called rounds. Geometrically, they're exactly the same as something called a fillet. A fillet would be a round on the inside of something, and a round is on the outside of something. But because geometrically they're the same, they're both arcs tangent to two surfaces, we can go over to features, and under features we can find the fillet tool. And the fillet tool can be used. There is no fillet here, but I'll just show you. I can put a fillet there, and I want that to be 0.5, and now I have a fillet of 0.5, but I can also put a round on these corners, and because geometrically they're the same thing, even though that's called a round, I get what I want. Now I'm going to go back over to the left where it shows me what I've selected. I'm going to select edge, and I'm going to press the delete key and get rid of it because all I really want is that. Now I have a fully finished part based on that drawing right there that is accurate. It does show those lines right there, which are called tangent edges. That's because the software recognizes that as one surface, this is another surface. But we can also just say, let's display it for real the way it would look. Looks like that. Now, again, this is really just to show you how the class itself would work. At this point, and maybe at some other points along the way, I would say I'm going to stop sharing my screen. I'm doing that now. Now I go back and you can see me talking. You'll see other people, you'll see students in what's called a gallery view. And if depending on how you set up your computer, you might see full screen anybody who happens to be talking. And then I will go and say, all right, Daryl, did you understand what I just did? And Daryl will say, yes, or well, no, not exactly. Could you go back and do something again? And I'll go back and do something again. But probably he'll say, yeah, I'll give me a thumbs up. He'll turn on the audio and say something, or shake his head. If you don't have your video on, you can either turn on audio and tell me you understand it, or you can go down to the bottom where there's these little things called reactors, and you can give me a thumbs up there. But that's how I'm going to do. I'm going to go back and forth, which means I'm going to interact with every one of you every class, because periodically I'm going to check in with every single one of you in the class to make sure you understand what I just did. That's your opportunity to ask a question, and that's where I want you to ask that question. Now, you're perfectly happy, perfectly entitled, perfectly, what's the word I'm looking for? Yes, you can just interrupt me anytime if there's something that doesn't make sense and ask a question. You'll be able to do that by turning off your mute and then saying something. So that's how we're going to do it. I think we're going to get through this. It's going to go fine. Again, I'd rather be in a classroom with you. You probably would rather be in a classroom as well, but that's just not the way we can do things right now. So we're going to make the best of this. You're going to learn this software. We're going to have a good time, and I can't wait to meet you. So right now I'm going to go and end this session, and I'm going to end this session right now.